This is lesson 6.5, okay? It's not going to take long. It's not going to be tough. If you're in 1010, all this log stuff is just going to come pretty natural for you. We just did it not too long ago. And that's good news. I feel like you guys need some good news. And that's good news because exponents and logs are a big part of this class. And you're really good at them, right? So that's good. Okay. So you really got to stick with me today. I noticed last period lots of people were writing and 2 steps ahead of me. Well, then you're going to miss all the details. And I can't do anything except ask you not to. I used to hate logs. I used to be like, they're so weird. Like, what am I doing? What is this? And I know a lot of people have the same feeling. But now that I'm like good at it, it's easy. All you have to do, truly, and I'm going to say this probably 10 times today, all you have to do is know the rules and apply the rules. That's all you have to do. So if you know the rules, then you should be home free, okay? All it is just knowing the rules. Okay, so go like this, and off to the side, I want you to put memorize, okay? I know what you can do. Josie, on the table, there's a list of all my students and all my classes, and we need to get grace cards written out. Will you have him do that? Show him, like, write the name 3 times, blah, blah, blah. Okay, so you have to memorize these. Okay, so the first rule is log base A of 1 is equal to 0. Okay, so off over here to the side, I want everybody to go EX, and I'm going to give you a few examples. Okay, for example, log base 7 of 1 is 0. Another one, log base 32 of 1 is equal to 0. I could keep going. You get the idea. Now, A cannot be 0, and it also cannot be negative, okay? It also cannot be 1, but that never really comes into play. Why is log base A of 1 0? Well, because if you convert it, look, you get A raised to the other side, which is 0, is equal to 1. Anything to the 0 is always 1. The next rule is log base A of A is a 1. Let's write a few examples out, okay? So everybody go log base 8 of 8 is 1. Log base 41 of 41 is equal to 1. You get the idea. If the numbers match, it's a 1. Why? Convert it. You guys look. A to the other side, which is a 1, is equal to A. It's always true. A to the first is always A. Okay? Question 3, or rule number 3. This is what I do to explain this and even to do it. See this exponent right here? I want you to pull that down in front. So I want you to write it as n times log base A of A. Okay? Log base A of A is a 1. 1 times n is an n. That's why you get an n. Okay? Let me give you an example. Log base 6 of 6 raised to the 3rd. Okay? That's a little example explaining rule 3. Pull the 3 in front. So you have 3 times log base 6 is 6. Everybody in the room, tell me, what is log base 6 is 6? What is log base 6 of 6? 1. And then 1 times 3 is 3. Okay? That's it. Okay. This rule right here, this is like a secondary rule or another rule to number 3. There's really not a way for me to have you figure it out. You just have to kind of memorize it. But it's super easy. So if you have 12 raised to the log base 12 of 2x, do you see how this base is raised to the log of the same base? Those like undo each other. So the answer is just whatever you're taking the log of, which in this problem is a 2x. Okay? Okay, one more thing I have to talk about, rule number 4. You can just sit and watch this if you want to for a second. Could 3 to the 2nd ever be equal to 3 to the 3rd? Tell me that. No. One's a 9, one's a 27. They're never going to be the same. So if they told me that 3 to the x was 3 to the 2nd, then I know that x would have to be what, everybody? X would have to be 2. Okay, so that's an easy thing to understand. Well, now we're going to apply the same idea with logs. Okay, so everybody write down log base 3 of x is equal to log base 3 of 8. Well, if log base 3 of x is log base 3 of 8, then x must be 8. Same idea as the other rule I just showed you, okay? Okay, now let's apply these rules. All we're trying to do is evaluate this, okay? So, if you see that exponent, pull it down in front. So everybody write x times log base 3 of 3. What is log base 3 of 3, everybody? 1. 1 times x is x. There you go. Okay? Question B, all you have to do is just look at it and remember. So this is 5 raised to the log base 5. What's my answer, everybody? 7. Easy. Know the rules. That's all you have to do. Okay, stop on question C for just a second. You guys, 85% of the time that I see an ln, I write it as a log base e. Because it's easier when you can see it as a log base e. Let me show you what I'm talking about. Everybody write down log base e of e to the 3x power. Now pull the 3x down in front, so you have 3x times log base e of e. Everybody in the room, what is log base e of e? 1. What's 1 times 3x? 3x. That's easy. Know the rules, okay? Okay, here's question D. Now, I want you to freeze right here. This one's a little bit trickier. I see the ln. I know that ln is log base e. I can see I've got an e in the denominator, okay? I know that the author of this problem is trying to get me to write it as log base e of e. Because if I can do that, then I know log base e of e is a 1, okay? So let's write this as log base e of. I'm going to take the e to the 4th that's on the bottom, I'm going to pull it up to the top, and I get an e to the, talk to me, negative 4th. Good, change the sign. Now pull the negative 4 out in front. Negative 4 times log base e of e. Log base e of e is a 1. 1 times negative 4 is a negative 4. And I got it. Who says I'm good? Let's see. Okay? I told you guys you were smart. You're all sitting here sulking, worried about your grade. You're smart. You're fine. Okay. Question E. E raised to the log base e of 3. So I've got an e raised to the log base e. What's my answer, everybody? 3. See? You're smart. It's easy. Everything's happy. Okay, 2a. Log base 6 of x is log base 6 of 17. Therefore, x must be, talk to me, 17. Whiners. Log base 17 of 17. What's that equal to? 1. That's it. Okay? Okay. Question 3. I want everyone to freeze right here for just a second. Okay? Look at example 3. Look at A, B, C, D, and E. They all look different. None of them are the same, right? Up in the directions, I want you to write the words 4 digits. So we're going to evaluate these 5 things and we're going to round it to 4 digits past the decimal, okay? Everybody go log 32, close it off, hit enter, and I get 1.5051. That's what that's equal to. Okay, look at question B. Question B looks different. That's all right. Go log 16, close it off, plus log 2, close it off, hit enter. I got exactly the same thing. So those 2 things look totally different, but they're the same. Let's do the next one. Log 4, close it off, plus log 4, close it off, plus log 2, close it off. I get the same thing, 1.5051, and all 3 look different. The next one, 5 log 2, close it off, enter, same thing. The last one, log 64, close it off, minus log 2, close it off, exact same thing. Okay, listen what I want to say to you right now. They all look different, but they're really the same. I could choose any one of these. Let's say I chose B. You don't have to box it or anything, just listen. I could turn log 32 into log 16 plus log 2. I could turn C into B. I could turn D into B and I could turn E into B. I could make it look the same. How would I do that? I would use the rules and I would split them apart, or I would just do different rules to them and make them look the same. That's all you do with logs. You have something, you start changing it according to all the rules, and you simplify it or evaluate it using the rules. Who says I understand what you're saying? Let me see. Great. Okay. Off to the side right here, I want you to write the word memorize. The reason people struggle with logs, because they don't know the rules. They don't know the rules, okay? Okay, on the left side, I want you to put condense. And on the right side, I want you to put the word expand. Then across from product, put a equal in the middle. Equals and equals on quotient and power. Now I want you to talk to me. If a balloon is expanded, is it big or is it small? What is it? It's big. So off to the side on expand, I want you to put big. Condensed soup means soup that's like has the water taken out of it. That's what that cream of mushroom soup is, condensed soup. You're supposed to add water to it to make it how it's supposed to be. So condensed is squished in. So this is small. Okay? So remember that. Condensed small, expand is big. Okay, product property. You guys know product means what? What does that mean? Multiply. Good. So everybody write down log base A of mn. And I put the mn in parentheses because I think it's very clear if you do. Okay? Now you tell me, if they're squished together and they're multiplied, when I expand them, what do I do? Everybody talk to me. You add. Very good. So this is log base A of m plus log base A of n. Okay? Quotient. Quotient means what? Divide. So it's going to be log base A of m over n. What do you do when you expand if you divide when it's condensed? You subtract. Good. So it's log base A of m minus log base A of n. The power property, we've already talked about this. So if you have log base A of m to the n power, when you expand it, you pull that n down in front. So it's n times log base A of m. That's it. So most of you knew those rules anyway, right? Okay, let's do question 4. Expand. Please don't go ahead of me, okay? Please don't go ahead of me. I want you to grab your pencil and I want you to throw parentheses around the 2xy. When I expand this, I'm going to write log 3 times. One for the 2, one for the x, and one for the y, okay? So everybody write down log base 2 of 2 plus log base 2 of x plus log base 2 of y. When they're multiplied, you add, right? Okay, you guys know Weber State loves all or nothing questions, right? If this was an all or nothing question, you would get nothing. Why? Is what? That's a 1. Good. So you have 1 plus log base 2 of x plus log base 2 of y. Put a box around it and you're done. Okay? Question B is where you really want to pay attention. Okay? I want you to put brackets or parentheses around the 4 over x times 7. Okay, I want you to listen. I'm going to write the word log 3 times. One for the 4, one for the x, one for the z. Who says I understand that? Okay. Anything that's on the bottom has a negative sign. So the x and the z will have a negative. It's very simple. So you just go log base 3 of 4 minus log base 3 of x minus log base 3 of z. Literally, that's your answer. That's how easy it is. Very, very straightforward. Okay, I want you to freeze right there. Does anybody have a question that they want to ask me? I did not do anything wrong. I did not do anything wrong. That is the answer. Okay, can I guess what you're going to say? I would like your permission, because I think it's fun. It makes me feel happy when I can read people's minds. I do it all the time. It's kind of freaky. This is what you're saying. This is what you want to say. The x and the y are multiplied together. And when you expand those, you're supposed to be adding those. So why is this not a plus? Is that what you were going to say? Are you telling the truth?
But why can't you put it in parentheses?
You can, but the definition of simplified means no more parentheses in your problem. Okay? So a lot of people, that question I just asked right there, why isn't that plus? A lot of people ask me that question, and they will actually make it a plus. Okay? It's not a plus. I'm going to show you one time why it's not a plus. Then I want you to erase it from your brain, and I want you to go bottom, negative, top, positive, done. I mean, that's how easy. Okay? Everybody write this with me. Everybody go log base 3 of 4 minus log base 3 of x times z. Now, that's not fully expanded, right? So I have to expand that. So I'm going to go log base 3 of 4 minus, you guys, that negative affects both the log for the 3 and the log, or the x and the log of the z. So you have to go parentheses minus log base 3 of x plus log base 3 of z. Then, so what he was saying is, why can't you leave it like that, right? He understood it's because it's not simplified. So if you distribute that negative through, then the log base 3 of x becomes a negative, the log base 3 of z becomes a negative. That's why it's negative, okay? Who says I understand that? Okay, now look what I want you to do. Erase it from your memory. Don't think about it. Just make it easy. Bottom, negative, top, positive, go. Easy, okay? Okay, question C, it's really almost expanded. There's just one small thing that we need to do to expand it. What is that? Pull the 3 down. Yeah, so very simple. 3 log base 2 of x, done. Okay? Okay, question D, put parentheses around the x, y, and z. Everybody in the room tell me, how many times will I write the word log? 3 times. One for the x, one for the y, one for the z. Okay, so we have log base 3 of x to the 3rd plus log base 3 of y to the 2nd plus log base 3 of z. If this is an all or nothing question and you're done, you just got nothing. Why? Exponents, right? So you have 3 times log base 3 of x plus 2 times log base 3 of y plus log base 3 of z. There's your answer, and you're done. Okay, look at question E. Answer these questions before you begin, please. How many times will I write ln? Tell me. 3. Of those 3 times, how many will be negative? 1. Which one? The x. Why? It's on the bottom. Okay, so you go ln y to the 2nd plus the ln of square root of z minus the ln of x. Now take your eraser, get rid of the square root of z, write it as a z to the, tell me, 1/2. Good. Now what do I do to finish? Pull your exponents, right? So you have 2 ln y plus 1/2 ln z minus ln x. That's your answer, and you're done. Easy. Who says I'm totally good with this? I get this. Great. Okay, now we're going to go the other way. Now it's expanded and we're going to condense. You have to go in exactly the opposite order that we just did. So what was the very last step that we just did on the ones before? Exponents. So what are we going to do first? Pull them up as exponents, right? So this is going to be the log of x to the 1/3 plus the log of x minus 3 to the 5th. Now, take your eraser. Erase the 1/3. Don't write it as an x to the 1/3. Write it as, tell me, the cube root of x. Now I'm ready to condense. They're added. When I squish them, they're going to be multiplied. So this is going to be the log of the cube root of x multiplied by x minus 3 to the 5th. You guys, that looks so complicated. It's complicated. So be clear and put brackets around what you're taking the log of. Do you have to do that? Nope. Do I think it's pretty smart? Yes. Go up above to the directions on example 5. I want you to highlight the word condense, and I want you to write down the words write, then in quotes put log 1 time. Write log 1 time, not twice, just once. See in my answer I have log 1 time. I squished it all together. Okay, question B. What do I do first? Exponents. So this is the ln of x minus 4 to the 4th minus the ln of x to the 2nd. Now I'm ready to write it once. I know I'm going to have a division because I have a negative. The guy that's the negative goes on the bottom, that's the x squared. The guy that's the top, the positive goes on the top, that's x minus 4 to the 4th, and I'm done. Who says got it? Let me see. Okay, good. Okay, question C. Exponents. So we're going to go the log of, now I'm not going to write x to the 1/2. What am I going to write? Square root of x. Let's go right to that. Then go plus the log of y to the 4th minus the log of 4 minus the log of p to the 6th. I'm ready. I'm going to do log 1 time. It's going to be complicated, so I'm just going to do a big bracket. I know I'm going to have a fraction. Anything that's a negative goes on the bottom. So I have a 4 and a p to the 6th on the bottom because they're negative. On the top, I have a square root of x, and I have a y to the 4th, and I'm done. Okay? I want to show you something. Look right here. I have never remembered to show this to my classes until this year. Look what people do. They're like, okay, look what I've got. I know this is going to be 1 log. Okay, the square root of x is on the top. Don't write this down. The y to the 4th is a positive. It's on the top. The 4 is a negative. It's on the bottom. This p to the 6th is a negative. That means divide that by p to the 6th. Common. No. Just simple. Negative bottom, positive top. Done. Don't do this. Okay? It's not that. All right, let's do question D. Okay, look right here for a sec. Do you see how you have log base 2? And then that is a number with no variable. What the author of the problem is trying to get you to do is to write it as log base 2 of 2. Now, if that says log base 2 of 7, we're never going to be able to write that as log base 2 of 2, right? But an 8, could I write log base 2 of 8 as log base 2 of 2 to something? Yeah. So it's leading me that way, right? So everybody go log base 2 of x minus 1 squared minus log base 2 of 2 to the 3rd plus log base 2 of x plus log base 2 of 2 to the 3rd. Well, now look what I've got. I've got negative log base 2 of 2 to the 3rd and positive log base 2 of 2 to the 3rd. Those go away. So now I have log base 2 of x minus 1 squared plus log base 2 of x. Now I'm going to squish it into 1, so it's log base 2. Those are added, so when I squish them, they're multiplied. So I go x times x minus 1 squared. I'm going to choose to put brackets, and I'm done. Yes, sir?
Could you put the x at the back?
You could, it's just awkward. But yeah, it would not be wrong. I just always push it to the front because it's natural. Yeah, you could, but that would be fine. Okay, let's do question 6. Look at the problem. Look at the left-hand side. Is it equal to the right-hand side? What do you think the answer is?
No.
I think the answer is no. Why are you thinking false?
Because it's condensed, but there's 2 logs
It's a beautiful answer. It's condensed on the right, but we've got 2 logs. So my gut is saying no. My gut is saying it's not true, right? They want me to justify my answer. So let's actually go through and like prove it, okay? So take the left side and let's condense it into 1 log. So it's going to be the log. On the bottom is the 3x. On the top is an x plus 1. On the right-hand side, just leave it alone. You guys, for all we know, those are really the same. They look different, but that doesn't mean that they're not the same. So the answer is false. These are not equal to each other. How could I prove that it's false? Like I could graph the right and the left and show that the graphs are different. I certainly don't want to do that. Can anybody think of a pretty simple way that we could prove that they're not the same? Think about that. Every class period someone's been able to come up with this. You guys are smart. How could I prove that those 2 things are not the same?
Expand the right side.
You could start, expanding those out, yes. But where you have a log over a log, I don't really have an expansion rule for that. But yes, you could start manipulating them, okay? What could you do? You got it, girl. Plug in a value. Plug in a value. See what you get on the right, see what you get on the left. They're the same or they're not. That's perfect. What's a number that I don't want to choose? Definitely don't want. I don't want a 0, and I don't want negatives, right? Because then I'm going to be taking the log of negatives. So I don't want that. So let's choose something very, very simple, like x equals 1. Okay? And then everybody go the log of 1 plus 1 over 3 times 1 is equal to the log of 1 plus 1 over the log of 3 times 1. Now you have to know how to put these in your calculator to be able to answer it correctly, okay? The left-hand side is the log of 1 plus 1 is 2, divided by 3 times 1 is 3, close it off, hit enter, and I got negative 0.1761. Let's see if I get the same thing on the other side. So I'm going to go log 2, close it off, divided by log 3, close it off, hit enter, and I get 0.6309. So now I've proven it. Now look at that final statement that I just said. Is it true that negative 0.1761 is equal to 0.6309? No. So I've got to make those not equal to, or I'm saying inaccurate things, and therefore I know my answer is false. Okay? Who says I'm good? Let me see. Raise your hand. Okay, great. Okay, question 7 we've already done. That was the change of base formula. We had to do it last time to be able to do our assignment, okay? So now we've just got 8 and 9 and we're done. And I will tell you that 8 and 9 are pretty important. They're very probable that you will see these often, okay? So just watch these very closely, okay? I want you to write a note to yourself right there. And I want you to say, expand fully first. So the first thing I want you to do is to completely expand this, okay? So I'm going to say log 3 times 1's going to be a negative. So I'm going to go log base b of b squared plus log base b of c to the 4th minus log base b of d. Is that fully expanded? Is it yes or no? Sorry. It is not. What do I have to do? My exponents. So I have 2 times log base b of b plus 4 times log base b of c minus log base b of d. Now I just substitute in. Guys, look. Log base b of b is a 1. So that's just 2 times 1. Log base b of c is 3.6. So that's plus 4 times 3.6 minus log base b of d is 1.2. Grab your calculator and you're done. 2 times 1 is 2 plus 4 parenthesis 3.6, close it, minus 1.2, hit enter. I get 15.2 and I'm done. Seems so straightforward. Seems so easy. Who says, yeah, I think that feels so easy? Okay, I want you to watch me do this wrong. Watch me do this wrong. Okay, everyone just sit back. Okay. Log base A of a to the second times 1.1 to the third over 0.7 to the fourth, close that off. It's wrong. I want you to tell me why it's wrong. I need everyone to look and figure this out, because maybe if you can figure it out, then you won't do it. I don't want anybody to say it's wrong because you didn't expand it first. Well, I told you to expand it first. I want you to look at what I did and tell me why what I did was wrong. What did I do and why is it wrong? Can someone tell me that? Go ahead, bud.
It's because B doesn't equal 1.1 and C is not equal to 0.7. It's log base A of B.
Yeah. Look what I did. I said that B is 1.1. Well, that's only true if they tell me B is 1.1. They didn't say that. It's log base A of B that's 1.1. It's log base A of C that's 0.7, not C. Who says I understand that? Raise your hand. Okay, yay. So please don't do that. Okay, let's expand it. So everybody go log base A of A to the second plus log base A of B to the third minus log base A of C to the fourth. Pull your exponents down. 2 times log base A, oh, stop for 2 seconds. Freeze right there, freeze. Another thing people do wrong, I just want to show you. They go, that's 1 squared plus 1.1 to the third minus 0.7 to the fourth, and they get it wrong. Why is it wrong? Yeah, that 2 is not an exponent. It's supposed to be down in front and multiplied by 2. The 3 is not an exponent. It's supposed to be pulled down in front. They didn't fully expand it. So just please be careful with that. So now we go 2 times log base A of A plus 3 times log base A of B minus 4 times log base A of C. Log base A of A is a 1. 1 times 2 is a 2. Log base A of B is 1.1 minus 4. Log base A of C is 0.7. Grab your calculator. That's going to be 2 plus 3.3 minus 4 times 0.7. Hit enter. You get 2.5 and you're done. Okay, who says I'm good? Let me see, raise your hand. Okay, yay.